Go ahead.
My name is Everett Hinckley. I'm the National Remote Sensing Program Manager for the Forest Service. And I enjoyed all the presentations this morning, but Jarlath's presentation was especially engaging for me. I've worked with some of the people in the room here in forming up a remote sensing group for urban forestry. And so I would like to encourage anyone in the room who's interested in pursuing the remote sensing aspect to contact me. I'd like to contact Jarlath after the conference here and kind of expand this network of people that I've been working with. And part of this is to explore data sets that are existing and available to assist in this fine scale remote sensing analysis of the urban forest canopies. So that was just a comment, not really a question.
Would it be okay if I just responded to that? I think one of the points that I forgot to hit home is a lot of the mapping analyses that we're doing are really only possible because other agencies have put forth the funds to purchase this data. Those agencies may be federal or they may be state or local. And I really encourage, I always encourage the communities we work with to stand up and advocate for those data because they're not being done for the sake of urban forestry. I hate to say it, you know, the people that fund these imagery and LiDAR programs, that's not their primary goal in mind. So we really are riding the coattails of others who have decided to step up and put forth this money for a variety of mapping purposes. So the question was, what are the primary purposes? And typically the crucial data sets such as LiDAR are done for topographic mapping. It's very expensive if you're doing construction to send out survey crews to an area. So if you have a community with LiDAR, it's there. New York City, the driving factor for the LiDAR data that we used was a solar map for the city, looking at solar potential mapping on the tops of buildings. The imagery that most of the groups use that do this type of tree canopy mapping, the NAPE or National Agriculture Imagery Program data, leaf-on data acquired during the summer, done by the USDA for the purposes of crop compliance mapping. Of course, its uses go far beyond that, and fortunate that they don't stop at the city borders and say the urban ag isn't worth it, but we're really lucky to have these data sets out there that allow us to do these things because the cost would jump considerably if we did not have those, and especially for these large areas, the accuracy would be reduced.
If I could follow on to that, Jarlath is right that LiDAR can be used for many different purposes, and the output products from the data collection can be very different. And one of the things the USGS is working on right now is a 3D elevation program, which would be nationwide LiDAR coverage. And so I'm working with the USGS to make sure that the products that are being collected by the LiDAR vendors will be useful to the forest community, because we want to make sure that they retain the biomass and don't just strip that data off and end up with a bare surface model. And also the density that the data is collected is very important in terms of how useful it is to the forest community. And so there's a whole host of factors that have to be considered. And if we end up developing a national data set, that would be very valuable for these type of analyses. So.
Next question. Are there? Oh, go ahead.
Yes. Hey, I'm Michaela Milton, biologist for the National Park Service in DC, and those in my breakout group probably already heard this. But I have a question from a manager's perspective. Being able to add ecosystem services data to tree valuations when we're calculating mitigation costs, and have tried using iTree and have not been successful for natural areas, just individual trees or a small group of trees. And maybe I'm not doing something right, or maybe that's coming, I don't know.
So the question is, can you use it in natural areas?
Right, for individual trees or a small group of trees. Say
yeah, it's scalable, and
somebody's going to chop down trees on us, and I want to add the ecosystem services valuations to the landscape value of those trees for calculating mitigation costs.
Yes, you can do it. You'd have to get the data on the trees for that area, so either inventory or sample it. The model can run urban and rural. It was built as an urban model, partly because I work in an urban unit, and there's much more data in urban areas than there are in rural areas, such as pollutant monitors and weather systems. But it's a physically based model, so if you move the tree to the rural area, as long as we have similar weather systems and pollution, but you have to have the tree data.
Right, when I was looking to calculate that, there weren't, like, there was a drop-down list of species, and not all the species I was interested in were listed there, for example. I think there was something on the Casey Trees website that was built off of iTree that you could calculate for individual
Oh,
trees, and,
are you talking iTree or you talking the tree benefit calculator?
well, whichever would be most useful for this scenario.
Yeah, I would use iTree. iTree has a database of about 5,000 or 6,000 trees in it, and once, as we go international, we add more species to the database. So most of the trees in the U.S., if not all, should already be in the database. So it might be one of the tools you're using, which the calculator might not have all the species from the database. So you can go right to iTree and run it directly from iTree. The calculator is a little bit different. It's a simple stripped-down version for homeowners to just make quick calculations. But the actual iTree program has all the species database and all the weather systems, all the pollution data. You can run it through ECO. We can talk afterwards, but there are ways to do it.
Good morning. Thank you all for your presentations. This is for Dr. Jackson. I appreciated your talk. You deal with an enormous and challenging domain of health benefits. And one of the things I was struck by when I was listening to you is that we're relatively thin on the health benefits data, and we need many more studies, especially if we're going to start doing these meta-analyses. So there's some lovely studies out there, but they're few and far between, and we need more work. There's also some of this work on the particulate matter suggests that, well, under certain conditions, trees may not be good. And I think we have to take that information in a larger context, because trees are so good in so many other ways. And when we look at the work on our capacity to pay attention, or our capacity to form bonds with our neighbors, or the reduced levels of crime, or lower levels of aggression and violence in home, it'd probably be helpful to be building more sophisticated models than looking at these single outcomes. So we need more studies on more of these health outcomes, and then we need more integrated and rich studies that or capacity to model these things in a richer fashion. Because if there are negative health outcomes associated with trees, and I think the jury is clearly still out on that, we need to build that into a larger context for understanding the whole person, and not just looking at particulate matter, for instance, or looking at cognitive functioning.
Well, sure. So you're talking about like modeling, maybe on a population scale, all of the factors that go into well-being. That's a tall order. We do have I have some colleagues who are working on an index of well-being using work that's been started in Canada and Australia and Europe. And they have some papers recently out, an AMBIO and an EPA report, that list all of the factors that they believe are important to, like 8 pillars of well-being. And the interesting thing is, right away I noticed that those data aren't available. It would be great to construct an index at, say, the county scale, which they're proposing. So we're just very limited in many dimensions with data, with our understanding. And I'm a landscape ecologist, so I've taken an advanced epidemiology class, but that's still fairly thin in terms of a health background. And so interdisciplinary collaboration, of course, is just right there at the top, which we do. But I think we're just at the beginning of this tremendous challenge, as you point out. So I certainly don't have an answer, but I really appreciate that comment.
And if I could use moderator's privilege to respond, say yes, I think that's a really important point. And I would like to mention yesterday a couple folks, including Kathy Wolf, mentioned the importance of having public health part of the discussion about urban forestry. And last summer I participated in the City of Ann Arbor's health impact assessment of tree canopy, and it was a really great experience, in part because we had public health represented, but also stormwater, social service, public housing. So I think one of the things we did was use the tool that Laura presented to kind of identify what are the range of health impacts. And we specifically tried not to limit it only to the positive, because there are trees that fall, damage property, things like that. But I think the balance of the evidence, of course, is that it's good. But I think that you're right, doing careful comparable epi studies and trying to understand the mechanisms behind that is one big step towards better being able to apply the science to make decisions with public health in mind, along with the other benefits.
Hi, I'm Ann Harston Strang with Maryland DNR Forest Service, and I work with some of the Chesapeake Bay program issues. One of the things we're trying to do is improve the tracking for our BMPs, including urban tree planting. So this is a question for Jarlath. As part of our BMP verification protocols that they're trying to establish now, they're proposing to look at overall tree canopy cover and use a 5-year assessment to make sure that we're meeting a baseline of canopy increase in order to count increased tree planting as a BMP. Does that seem like a good application, knowing the data as you do? Because it's, certainly looks like a useful tool.
No, I think there's going to be a lot of challenges in doing 5-year interval work, depending on the data sources. If you take the primary data source that we've used in Maryland in the past, which is NAPE imagery, right, the accuracies of that are such that you're going to have sort of on the order of a 1 to 2 meter shift between the two data sets. Okay. And there's no good easy way to resolve that from different look angles. So as a result, you're going to be picking up an awful lot of false change. So I think in a 5-year interval, one of the things that you have to take into mind is that your error rates for mapping at each time period may be well with your change rates may fall within those error bars, right? So you're saying I've got a 2% increase in tree canopy. Right. Your mapping error may be at least 2%. So as a result, you're not picking up any change. I think if you go down to the level of detail that I showed up there, mapping individual change and then trying to verify it, that does help, but that becomes a little bit more costly. So I think that's very tricky stuff. The other thing, there's a tremendous bias towards loss. Because of the resolution of the data, we pick up loss before we pick up gains. Because gains, it's sort of very tricky to tell. Did that tree canopy really expand, or is it a shift in the data? We're not picking up those new trees that are planted because they're too small. So we have a bias towards loss over the short time as opposed to the long time. And I think there's probably some simple tools, such as what Dave has out there with some of the iTree tools of doing a sampling method, right? Where you drop dots on the map, and over time, you can do that, of course, and you lose the understanding of what perhaps is driving that canopy change, but that's much more cost effective and more easily done. And maybe, Dave, you can comment on what you think the accuracy of those techniques are.
Yeah, the approach, if you don't need the map, as Jarlath said, the maps are great, but laying over Jarlath talked about the problems. In iTree Canopy, which is a Google photo interpretation program, you can pair images, slide back on Google Earth, and have 2 sets of images right next to each other with the points located the same. The interpreter can overcome many of the problems of misregistration and interpret, did that point change? So back in 05, it was a tree, and now it's a building. And you can actually see it, and you can take notes on each point if you wanted to, what was the cause of change, if you could actually see. Or the tree just might be gone, so you don't know why the tree is gone, but you can statistically sample and check the pluses, both pluses and minuses of land cover change, and then do analysis of if your program statistically is going up or going down.
Right, and that might be manageable at a jurisdiction level.
Manageable at any level, as long as you have imagery. We recommend, what we found, we did the study of change in the United States, about 1,000 points you can find statistical difference, usually statistically significant change, if there is a change going on. It depends on the degree of change. We was talking to somebody yesterday, in China it takes 500 points. China developing so rapidly, change is occurring all over the place. In the US, it's more hit or miss, so you have to have a large enough sample size. You can do 1,000 points probably in less than a week and get a good statistical estimate. And if you need more and you're not detecting enough, you can always add more. It's just a random sampling program. So it doesn't do the maps. So if you don't need the maps, but statistically will tell you within a geography whether there's change going on.
Yeah, we would just need some protocol to verify that there's a baseline of increase.
Yes, that's the program you should use.
My name's Randy Neprash. I work with a number of cities in Minnesota that are regulated for stormwater discharge. I wanted to make a comment. It came up came up today, it also came up in our breakout session yesterday afternoon, which is that there's this interesting distinction between the quantification of benefits expressed in a variety of ways, but then also expressing it in terms of monetary terms. And in some contexts, the monetization is important, but in other contexts, the monetization is virtually irrelevant. On the regulatory side, for instance, compliance is compliance. Cost is in there in terms of order of magnitude, but not much else. In terms of project design, you're going to have high variability depending on location and the type of project, and your designer will handle the cost estimates as appropriate there. So that distinction is worth keeping track of. My question is for Dave, and Dave, I've asked you this question before, but it's worth bringing up in this context. On the stormwater side, one of our needs is the quantification of the influence of canopy interception and evapotranspiration of urban trees on the changes those have in stormwater runoff. And my question essentially, that's important in the context of developing regulatory programs and particularly credit systems, but it's also important in terms of project design and project review on the regulatory side. And so the question essentially is, how close is iTree to providing useful information on those functions in those contexts?
We've actually just given to Sally Clegg in the Chesapeake Bay program a simple calculator based, you have to run an iTree hydro. For what hydro does is simulate the stream flow at an hourly basis on a watershed basis. So you have to run the model, and then it brings it down to that question. If I change canopy cover or impervious in a simple fashion, it calculates the net change in reduction in runoff and also event mean concentration of the various pollutants. So there's a lot of calculations behind the simple calculator. The idea is, can we credit? We've sent it out. I'll send you a copy if anybody wants to review it. It's just very simple. Try to, again, bringing this complicated system down to a simple fashion where people can understand. It's basically increasing canopy cover, or I should say changing canopy cover plus or minus, changing impervious cover plus or minus. The important point is, where are you starting at? If I'm in a 90% impervious area, I have a different answer than if I'm starting in a 2% impervious area. So that's basically you have to know what you're at and where you want to go, and it'll calculate the change based on that watershed. So we are there. It's the question of now, is it in a right format that it can be used?
Great. I'll look forward to working with it. Thanks.
I'll send you a copy.
Okay, next question.
Hi, Shannon Ramsey with Trees Forever. We're a Midwest, Iowa-based regional nonprofit and end user for over 20 years of U.S. Forest Service research. And I want to thank the panelists we work with. Well, you guys are all fantastic, and the great group here of researchers. Dave, a question for you. With iTree, one of the issues that is a gap for us working with our utility sponsors, utilities typically, the regulators only count 1 year of, let's just say, in energy efficiency measures, appliances are only counted for 1 year. They do not grow year after year. They remain the same. Trees, on the other hand, grow, and benefits grow exponentially. So using iTree, the researchers backed us into a 1 year corner. We have now convinced the regulators that it's okay to use 20 years or 40 years. And so we would like to see tables that do that. We've had to develop our own using the McPherson guides, but it would be nice if we could have those calculations.
The issue of change, it can be done. We can project 20 years forward gross. The question is net, because not only are trees growing and being planted in the 20 years, trees are going to die. And that's the difficult thing that we don't have a lot of data on, is monitoring data of how much is the forest actually changing. Because we know some of these trees are going to die. We knew new trees are going to come in through regeneration. And that, we can make the calculations. That's not the problem. It's the assumptions that drive the calculation into the future, because we're projecting over a 20-year period. If you give us the right assumptions of mortality, we can give you a proper answer of what the future will be. And that's the hard thing, is there's not a lot of data on mortality and the rates that actually occur.
Well, we have plugged those in using those put out in the tree guides, like the Midwest Tree Guide that McPherson developed. But I'm just saying it is a bit of a disservice to not have those calculated automatically in 10-year windows, because that's what we're putting out to the public. So
Okay, yeah, version 6 will get there. That's the forecast model that's been built, but it's not out. Again, half the work is getting it in a user-friendly format. The calculator can do so many permutations of answers. We're trying to summarize it down to simple ones that people can run. Emerald ash borer attacks, Asian long beetle attacks, a storm, things that are events, or just typical 2% mortality, 3%, and working it. So version 6 will have a more, forecast will be integrated in almost every model by version 6 and
That's
have
great
future
news.
forecasting.
super.
Version 6, we're projecting 2014. It's going to be a big upgrade with landscape design and forecast. It's a big piece, but that forecast model's been 10 years in development. So stuff you're seeing coming out now is not something we just thought about. It's been in the process for the last decade. It just takes time to work all the kinks out and test it and things like that.
Thanks. So we are at 10 o'clock, but Lori suggested why don't we get the last two questions in the room, and then we can take a break and then reconvene here right at 10:20 for the next session. So Ian, I guess, is next. Yep.
Thank you. Dave, a few questions. In the
Please
workshop
introduce
agenda-
yourself just for the.
Sure. Ian Hanau, I'm based in Denver, Colorado, private consultant. Dave, a few questions. The agenda talked about disservices, and I thought maybe if you could talk to disservices and also costs, because there's a few programs within iTree where you can work with cost information too, because we really haven't talked about cost-benefit analysis. And then the quick one, if you could just describe the difference in the stormwater model from version 4 to version 5, because for one of the recent studies we did, it was a really, really big, 25% of the stormwater value that was in version 4, and I wanted people to be aware of that. So it's sort of three parts: cost and disservices and stormwater.
I tell my wife my list and never go more than 2 without writing it down. Now I lost them already. Okay, the hydro one I can start because that was the last one. The difference between streets had an interception program. The new version of hydro, which is integrated in ECO, is not interception, it's runoff. Interception is much higher than the effect on runoff. So what you're getting, why the reductions have dropped, we can still give you interception values, but the answer that I think people are trying to ask for water quality is what's the change in runoff. So now the new program, at least the difference is streets is probably still the same. ECO never had hydro in it until version 5. ECO is calculating just the change in runoff, which is much lower than the change of interception. Intercepting water is how much water is intercepting the canopy. It doesn't mean the water that's intercepting the canopy is actually changing runoff, because the soils can intercept the water and do things like that. So there are different units of outputs between the two models. Disservices. The disservices that we calculate, which positive and negatives. The negatives would be pollen, which we haven't put it in yet. Changes in pollution concentration through resuspension can actually go up for PM 2.5, which is a new module. Energy use can be negative, and VOCs are the pretty much 4 disservices that can go both. Energy can be plus or minus. VOCs, volatile organic compounds, are typically negative. Pollen's typically negative. And pollution can be plus or minuses, but there are negatives in there. So there are disservices. If anybody can think of any others that might pop up, but it's basically, they pop up through the calculations. And what was your third one? I didn't write it down.
Sort of which programs include cost impacts? I know iTree Streets does. I don't.
Streets does. Version 6 will have costs. The cost will be up to the user to input. So if we do the benefit side, if you put the costs in from the user drive, we don't know what your costs are. You can load that in. You can do a cost-benefit ratio. Again, on the fairness of this, we don't do all the benefits. It's a bunch on that list that we don't even tackle. So to do a true cost-benefit analysis, we're underestimating the benefits to start with. So your ratio is going to be low to begin with. If you put your cost, the true costs, we're underestimating, because we don't know aesthetics. There's a lot of things we don't know how to value. But you can compare against the ones we can value.
Hi. I have more of an invitation than a question, and this is, by the way, they're all excellent presentations. Thank you very much. But Laura, I'm Cindy Blaine with the Sacramento Tree Foundation, and we've been doing a study using the California Health Interview Survey from UCLA to overlay it, to correlate it with the tree canopy data we have for the urbanized areas in the Sacramento region to look at health behaviors and outcomes. And so the whole thing that you were talking about association versus causality, that's come up in some of our discussions, and we were working with a company called Urban Design for Health, and they have access to other health studies. A couple of people have talked to us about longitudinal studies that have been going on for a while. One of them are the Seventh-day Adventists out of, well, all over the country, and they've had a 20-year longitudinal study. And there's another one that's an elderly study, And what they're saying is that we can take that information, which is not just self-reported data like California Health Interview Survey, but it's like markers where they take their metrics all the time, and we can overlay the canopy information. So if you're talking getting other data, these people have access to public health, and we have access to tree canopy through Jarlath and various people. So, and I don't know, I mean, other people might be doing something similar. It seems like it's one of those things that people are doing in pockets, and I agree with the conversation, or whoever suggested it yesterday, that we continue this conversation somehow, if only through a Facebook group, you know. And so we'll talk later then. Thanks.
Okay, thank you, everyone. Thanks, our panelists again, and we'll take the break and reconvene at 10:20 unless there are any other announcements.
No, not right now.
Break time.
Oh.
Okay. Thank you.